So, we had some work time on the lab yesterday. For those of you that are at the speaker, that's what we did. And I just want to reiterate what I want to say about the lab. So, it is the daylight lab. You're going to make a equation for cosine. And basically, you could always just kind of start like this. So everybody just on this page or off in the margin, I'm going to give you a high spot and a low spot. Let's just talk about daylight. When do you get the most daylight? Say the date if you know it. Most daylight? June. Does anybody remember what that day is called? Summer solstice. June what? 21st. Write it down because that's the date. If you look at different cities, you might find 4 days in a row where they have the same amount of sunlight. But you should use June 21. Otherwise, if you pick just a random one of those 4 days that all has the same amount of hours of sunlight, what's happening is the minutes are different and it's rounding. And so you're going to be off a little bit. So use June 21. And here, when's the least amount of sunlight that you get when you're above the equator? The winter, what do you know what it's called? There's the summer solstice and, you know what, Tyler? Is this called the winter solstice? Okay. Well, we're going to use that as, do anybody know what month we're talking? We don't really celebrate this one, but it's in December. And we're going to go with December 21. Now, the problem is you can't really put that into an equation because those aren't numbers. Might be like June 21's a number. Not really a number. So what you do is you use the timeanddate.com. Remember, that's timeanddate.com. To change that, and you go, what is the time from January 1st? Okay, and you'll figure out it's day like 170, and that's not right on purpose because it's your lab. You have to figure it out. And this is how many days it is from January 1st. There's a little checkbox. Don't check it. It's like, do you want to do this special way? Just leave the default in there. Don't check the special little box. Just figure out from January 1st to June 21, how many days is that? All right? And then we got to figure out how much sunlight there was. Well, that's pretty easy because that also is under time and date. And you go to sun. One of the options, there's a lot of little menus, is sun. And you type in a city, and you find the longest, sunniest day. And you'll realize, oh, there it is, June 21. And let's say that there was 8 hours and 41 minutes. Do you think that means 8.41? Of course not. So what do you do to get 841 to change into 8 point something? Grab your calculator or use your iPad, and everybody right now, figure out what 841 is as a decimal. It's 8 point something. Hint, it's out of 60 minutes. I'll use the dice of destiny to call on somebody. If you don't know how to do it, maybe you should talk to the kid next to you. All right. Check with the kid next to you, see if you remember how to do that. No, we're not changing it to minutes, we're changing it to hours. It'd be a lot easier to change it to hours.
So it's 8.68 an hour.
Okay. So, Jack, what'd you do?
I did 41 over 60.
41 over 60, what'd you get?
0.68, and you have to add the 8, so you have 8.68, and then 3 repeating, kind of, but I just found it
8.68 sounds like a good call. All right. Do you get how we turned this date and amount of hours into a decimal? Now, one kid asked me, as I'm finding the other points that are like in between, how many points do you have to have? You have to have 13 other points because you'll need the top, you'll need the bottom, and you need a total of 15 points at least, there's no reason to give me 20. I mean, you can if you want, but it's not like I'm gonna think you're extra genius to find 5 more points. It would be smart to find some points on both sides of those. You don't have to, but you can kind of see the curve that way. All right, so some kids were asking me, do I have to like keep regular intervals between these points? No, you can just pick random things that work nice. Like you drag the little slider bar on timeanddate.com under the sun menu. You drag it over until you find one that works nice. Like let's say this one was at 8:30. Do you get how that would actually be super easy to change over? Because it's 8.5, 8.5. 8 hours and 30 minutes would change to 8.5. So you can totally use ones that work nice. Ones that end in 15 minutes are nice too. You know, like if it was one that was, 9 hours and 15 minutes, that's 9.25. So, all right, so you can use ones that work nice. You don't have to labor over them, but it might be more work to try to find ones that work nice. So do what you want, but just find me 15 points. All right, so you'll have a high spot and a low spot, and I just want to run through how you use those again. So I'm going to give you a high spot. Imagine for a moment, I don't want to use the real lab numbers, that we had on day 120, that we had 8 hours of sun. And let's say that on day 300, we had 4 hours of sun. Would you please take a moment, the midline is the most important thing, and figure out the equation that would go through these with cosine. And you need to figure out A and B and C and D. I'll pause for a minute while you try to find that equation. All right, so if 6 is the midline, then that should tell you what? A, B, C, or D?
The amplitude, so A.
It tells you the amplitude, yes, but the amplitude isn't 6.
Oh, yeah. The amplitude is 2.
Okay, so the amplitude is this part right here. It's like how high is it going from that dotted line to the 8, and that is 2, so you are correct. So this is a 2, and it also tells you another answer right away. A, B, C, or D? Oh, you don't know this one. The 6 is D. So it is the amount it's shifted up. Okay, so the midline is important. It gives you 2 things. It gives you the amplitude indirectly, and it is D. Okay, then B is, well, I'm starting to get used to this. Did anybody else just go right away to 2 pi over the period? If you're not that good at this, you might want to write this equation down. B is 2 pi over the period. And you might be like, but didn't you say the period was 2 pi over B? Yeah, that's the same equation, just rewritten. Okay, so this right there is always going to be 2 pi over the period. So what is the period? Well, the period is how much time it took to go from here to here. No, it's not. That's a common mistake answer. It was 180 to go from there to there, but you can't use 180. That's half the period. So you had 360. Who had 2 pi over 360? All right, awesome. And last but not least, this shift. That is simple. The peak of cosine should be at 0, but it's not. It's at 120. So it's been shifted to the right 120. So your final answer was y equals 2 cosine of 2 pi over 360 times x minus 120 plus the d, which is how far up it just shifted, which was 6. And there you go. Any questions about that? That is essentially the lab. And you just got to get these numbers right here from, you can't say like June 21, you got to figure out what number it is. And you can't say this as like 8 hours and 12 minutes, you got to say 8 point something, 12 over 60. All right. And I'm going to give you an equation now. Y equals 6 cosine of 2 pi over 13 x minus 7 is equal to 10. Nope, sorry, plus 10. Plus 10. You should be able to now tell me what the picture looks like. Just a rough sketch. It's obviously a cosine wave. You should be able to kind of re-put it together from this. Say, okay, well, I know the high spot would be here. I know the low spot would be there. You know the dotted line that runs down the middle? And see if you can do this. Pausing. Nola, tell me something to know about the graph.
The points or
Anything. What do you know?
the plus 10 at the end is like how high the first like upper plan.
Okay, so this plus 10 at the end is the midline. It's the line that runs down the middle. So depending on what you meant by, the first point at the end. And then this right here, that's 7. Can you tell me what that means? Yes.
It moves the maximum next point to the right side.
I think there's somebody using their cell phone. If you are, put it away, please. It's the first peak. The first peak is right there. And it's at 7. All right. Next. Jack, what did you get out of this?
Well, that's the period. So
Okay.
I got the second point, like bottom of the cosine graph.
The bottom of the point. Yep, right there. So that 13 tells you that. Do you go over 13 from this?
No, you do. I divided 13 by 2.
Nice.
6.5.
6.5.
Plus that with the 7.
6.5 and the 7.
So I got 13.5 and then my y is
13.5. You are correct. Nice job. Okay, then this goes like this. And then, what else can I tell from it? Jacob.
Amplitude is 6.
Amplitude is 6, so therefore, that's 6. And therefore, since that line's at 10, what's this max spot?
7.16.
Should be 16, right? So then, yep, this spot right here is 16 high, and it's at 7, so it's 7 comma 16. And the low spot here was at 13.5 because we added 6.5, half of this period to get there. And then, how low does it go? Well, it goes down 6 also. So from 10, you go down 6, you'd be at 4. Cool. We can actually go backwards then, too. All right. Any questions about that? Yes.
How'd you get the 13.5?
How'd you get the 13.5? All right. Would you agree that we got this 7 here because it was shifted over 7, and so we knew this distance was 7? You good with that?
Yeah.
Okay. Next, the period is 13. It's 2 pi over the period, and the period's 13. We don't add 13, though, because adding 13 would actually get us all the way to the next peak. And so instead of adding 13, we add half of 13. Do you get what I mean by that?
Yeah.
Because 13 would have been a whole period over, would have been where the next peak was. That's 13. So then to get this spot, we add half of 13. Okay.
Yeah,
Okay, so let's go look at a few problems. All of a sudden, don't let your brain just go, well, I've never done one like this, so I can't do it. You've never done one like this. This is true. But it's still a cosine equation. You still have a high spot. You still have a low spot. It just looks different. All right? So if I were you, the first thing I would do is try to turn it into a cosine graph. Figure out your high spot and your low spot, because you get, once you have those two and you got the time in between them, if you make this little picture right here and you figure out this and you figure out that, then this isn't that bad at all. You can turn it into one of those other problems. Okay, so try to think about how that would work. I'm going to be quiet and just let you try to figure out a high spot and a low spot and how much time it is between them. Pausing. We'll let the dice of destiny pick somebody. This is row 3. Last person. Mr. G. How did you figure out, and did you figure out the low spot first or the high spot first? What made sense to you?
Well, I saw that the low spot was 10 feet off the ground because it says it in the...
All right, since 10 feet off the ground. So you knew that this spot right here had to be at 10. All right, I like it. That's height of 10. But what's the time for it?
And then I knew it took 5 minutes to complete one revolution. So you could do 0 or 1, but in this situation, I don't know.
All right, so if you're gonna load, where do you load? Do you load at the bottom or you load at the top?
Load at the bottom, but if you're going around more than once, you can do it.
Okay, I agree. You could say that you start at the bottom or you could say that you start at the top. So I'm gonna say that we start at the bottom because that just makes sense to me. You get on the roller or the Ferris wheel at the bottom, so time is 0 there. Okay, and then just to make my wave look more logical to me, I'm gonna make the first peak there because over some time I get to that first peak. How much time does it take till you're at the top?
2.5 minutes.
2.5. Why not 5?
Because 5 is a complete.
Yeah, 5 would be you'd be back at the ground again. So 2.5 minutes. So this spot would be at 2.5 for the minutes, comma, a height of how high are you at off the ground? Dice of Destiny, how high are you at your highest point? Lauren. Hint has to do with the radius of the wheel. Okay, so if the radius of the wheel is 35, how far is it from here to here?
70,
Yep. And how far off the ground were you in the first place?
10,
So how high are you?
60,
Nope, you're at the top here. You're up here. And you're up 70 from there to there. This one's 10 feet off the ground.
80.
80, there you go. Okay, so it's 2.5 comma 80. Now that you got that, it just turns into one of these normal problems where this is super important, and would you please finish it? Figure out the equation for this thing.
I don't know.
Okay, would you agree, since they told us the radius of the wheel was 35, that this is 35 and this is 35? Right? If that's the radius of the wheel and the wheel's kind of like this. Okay, so then 35 up from 10 makes this at 45. Another way to do that is just to take the 80 and the 10 and average them. Add them together, divide by 2. Once you got that line down the middle, you're almost done. Y equals the amplitude, which was 35, cosine of, I'm going to just put B for now, x minus the x value of the first peak, which was 2.5 minutes, and then plus the 45 is the midline. That make sense? Now the B term. The B term is the hard one, and that's, well, it's 2 pi over the period. And the period in this case, how long does it take to go a complete cycle? 5. So there it is. So B is 2 pi over 5. There's your equation, except put the B in, and you guys get that? All right. So you have to be able to adapt to all kinds of weird things. I'm going to give you one more weird one. Ready? I have a nose. And I have a finger on my hand. And if I have, that may be the single worst hand ever. So I'm going to just go with, this is my finger, and that's a finger. Okay, and there, this is my arm attached to my finger. So if you can see this in my class if you're in my classroom. If I hold up my hand like this, and the closest I ever get to my nose is 8 inches, do you get what I'm setting up here is kind of like the Ferris wheel thing, where the closest it ever got to the ground was 10 feet? Okay, well, the closest that I'm ever going to get to my nose is 8 inches away. But then I'm like pointing at somebody who's very aggressive, like body language. So people don't like to be pointed at like this. But if I were to point at you like this, Okay, then do you get, my hand is swinging in an arc, and it's going from 8 inches from my nose to, let's say that it is 20 inches from my nose when it's at full extension. This is my finger again, 20 inches from my nose. So I'm going back and forth between 8 and 20 and 8 and 20 and 8 and 20 and 8 and 20. It's like your mom going, you aren't going to go out there anymore. Stop hanging out with that kid. He's getting you in trouble. Okay, so anyway, you've got the finger wave going back and forth and back and forth. And then let's just say that I can do a complete cycle, like forward and backwards in 1 second. For a complete cycle, not just forwards and backwards. Write an equation for that. You can write a cosine equation. If I'm going to just do it regularly, forward, backwards, forward, backwards, forwards, backwards, you can write an equation for that. 1 second to do a complete cycle. You should be able to do this. Did any of you make a curve like this for cosine? That would have been smart. If you haven't already, you should do it now. And you might be like, what's the peak? Well, the peak is when it was at the max distance, the biggest number we have, which is 20. It was 20 inches away from my face. And if you're like, you know what, this makes more sense to me if I say that the wave kind of goes the other way, where it starts out low and it ends up high. You can do that too. All I need is a low spot and a high spot. You don't have to start with the low spot. Would you please talk to the person next to you about what you think the low spot and what you think the high spot are? Pausing. If you haven't already, then you got to figure out the times that go with these and then figure out the equation for it. So, it would be very wise for you, even though the lab isn't going to be due until after the test, it's going to take you X amount of time to do your lab. So it takes you an hour. Do you get it's going to help you study for the test at the same time as you're doing it? Because there's questions like that on the test. So wouldn't it be smarter to do it before you take the test? Like if you're going to spend the same hour, why not do it before the test? Even though it's not due till after the test. It gives you a little margin in case you're like too busy to do this. You don't have to, but it'd be smart. So I noticed there's only one kid's turning lab in. And I know some of you needed today's info, but take advantage of that. Get the lab done. You're studying for the test at the same time. Okay, you should have figured out that it kind of is your choice. I didn't say that I had to start 8 inches away and end 20 inches away. I could have started at 20 inches away and then went back to 8. So I couldn't have marked it wrong if you did it the other way. I personally meant that you started here, so time would be 0 at 8 inches away, and at time 0.5 of a second, half of a complete cycle time, you were at 20 inches away. That's what I meant it to be. Could you have said that you started here? Yeah, you could have said time was 0 at 20. That would have been okay. And then you would have said, you would have done the other part like down here and said, then I went to here. So you could go back. It's back and forth. So I didn't say where you started. All right, so then I need the dotted line down the middle. That for sure is the average of 20 and 8. So that's 28 is 14. And then I'd go y equals 14 to 20 here. I'm figuring out the amplitude is 6 cosine of 2 pi over a period is 1. So just 2 pi. And then x minus the first peak is 0.5 the way I did it. but you could have done it a different way because I didn't say where to start. And last is plus 14. Do you guys agree these are getting kind of easy? Good. If they're not easy for you yet, maybe go watch the video over again later and see which part you're not getting. All right, to move on. This is another Ferris wheel one. I feel like you do not need to do it with me. We just did one like it. If you'd like to do it for practice, feel free. Here's another one. It's a yo-yo. Do you get how that could go low and high and low and high and low and high? And same idea. My best advice on this is right away, figure out your high and your low, and then you'll get into the cosine frame set mindset. And this one, it doesn't really make it super obvious, but you got to figure out your low and your high. I'm not saying this is it, but if it were, then you'd go, oh, okay, my low is here and my high was here, and once again, I'd figure out something like that. And it's once you get that frame of mind, it's easy to do these. All right. So those are some practice on the hardest one on the test and what the lab is about. And they're only hard because it's hard to figure out what these are. Once you've got them, it should be easy by now. Finding that line down the middle is super key. Okay. Yay. And that's all I got for the video for today.